Okay, ladies and gentlemen, let's take a look here. Look at what we were doing as we proceed to answer these additional kind of limit questions, right? So I'm going to remark about this. Let's do a quick remark, and I'm going to try to write it down a little bit better. So if I have to take the limit as x goes to -2 of what? X cubed plus 8 over x plus 2. Okay. All right. I think this is where we left off. Is that true? All right. Now we're getting into some interesting kind of things here. Okay. We're getting into that. Now let me remind you guys something important here. You're looking at a rational function. And historically, rational functions have a concern where the denominator is 0. Historically, you have a vertical asymptote where that denominator is equal to 0. And the equation of such, you subtract 2 from both sides, you say x is going to be -2. However, ladies and gentlemen, be very careful. This only applies, and I'm going to get rid of that because that's not even the case. This only applies if what? The rational function is already what? Simplified. So that has to be a simplified rational function. So you're like, oh, that doesn't have a vertical asymptote? No, doesn't. And so even if you just proceeded and you said, okay, I'm going to try to evaluate that limit by using direct substitution, right? You say, what in the world is that? Well, plugging in the -2, directly substituting -2 here, what do you end up with? -8 plus 8. Well, -2 plus 2 is 0. So you actually end up with 0 over what? 0. Now remember, that has very special meaning for us in calculus. That's an indeterminate form, cannot determine. All right. So you might say, okay, what do you do in that case? Well, you always use what we say is what? Algebra. Now you say, what do you mean algebra? Well, this rational is not even simplified. And you go, okay, now how do I know? Well, a lot of these problems are very specially chosen, so we know ahead of time, you know. But you might say, well, how do I use algebra here? Well, you can divide. Or you can what? You can factor. Now, that means you got to remember how to factor. And this actually is a beginning algebra issue. It's a beginning algebra question. You guys remember how to factor x cubed plus 8? Right? This is part of the special factors. So you get a cubed plus what? B cubed. A plus B. A squared minus AB plus what? B squared. That's the special factor for the sum of perfect cubes, right? So you say, well, am I going to use that there? Yeah, because 8 really, if you notice, what is 8? Yeah, it's actually 2 cubed. So the numerator can, in fact, be factored. So you go, how do I factor? If I write it down, what is that? X cubed plus 2 cubed. I'm going to use this formula. X plus 2, x squared minus 2x plus 2 squared, which is what? 4. Okay? So that's my numerator now. So then you say the ratio really is x plus 2, x squared minus 2x plus 4 over what? X plus 2 cancels. And then you're left with what? X squared minus 2x plus 4. So that when you try to take the limit now, as x goes to negative 2, okay, what do you guys think happens now? Yeah, you're going to use, they call that direct sub. And I'm going to remind people here, just so you guys know, what's nice about that particular function. This function is a nice and amazing, it is quadratic, but it's a polynomial in general. And polynomials are nice and, they're the most beautiful functions we can work with. However, by direct sub, we are now able to what? Get 4 plus 4 plus 4. Oh, what is this going to be? Let me make sure I do my arithmetic okay. 4 plus 4 plus, isn't this 12? So, ladies and gentlemen, you say, well, what in the world does that even mean, Mr. Judge? Well, the limit is 12, okay? And you might say, well, what just happened at the location negative 2, 12, right? You go, what's going on here? Well, I do have the graph. All right, we do have the graph here. And what do you guys notice? There is a hole. Is that true? And let's see if we have the right address, by the way. Yes, it's negative 2. And what is this here? 2, 4, 6, 8. So like 6. Let me double check. This should be what? 12. Is that true? Let's double check. Did we do everything okay? 4, 6. That looks like it's 9, isn't it? I don't know. I'll have to double check here. All right. So it looks like 6, 7, 8. So it should be a 9. Anyway, well, I'll double check that, but there you go. You're gonna have a hole there. So I also want to remind you guys this here. Let's note something here. Okay. What is f of negative 2 here? If you try to plug in negative 2. Because you have a what here? A hole. What does that even mean? It's undefined at negative 2. Is that right? All right. And what else does that mean? F is what? Discontinuous at x equals negative 2. So from my calculations here, and I'll have to double check if I put the right curve there. I hope I did. That should be a 12. Whatever. All right, we'll double check. So the limit is 12 as you approach the left and the right, but the value of the function is undefined. All right. Now, how does that similarly affect? And the question that we had yesterday is, hey, Mr. Judge, can you put a point back in? Yes, you can. You can put a point. Like in this case, you have the limit as x goes to 4, which is 3. But now f of 3 is going to be negative what? Or f of 4 is negative 3. Here's where 4 is. So you can put a point back in, just so you guys know. All right, so I just want to let you guys know here now. Here's an example of that. So you might even say to me, well, what's going on? They're going to always want to see, do you understand things like this, right? Where is the issue, ladies and gentlemen, for this question here? The issue is around 2 here, okay? So what they're going to want to do, they're going to, for that example, I'll do it here. They're going to want to say, what's the limit as x goes to negative 2 now? And let me double check if everything's okay. X squared minus 4 over x minus 2. Okay. So even if they just give you this question, let me move it down here, and you proceed to apply direct substitution here, okay, what's going to happen as you apply direct sub? If I can get the right color here. Negative 2 squared minus 4 over, and oops, is it plus? No, that's minus. X minus 2, that's going to be a positive 2. I apologize. Okay. So, alrighty. So you get 2 minus 2. 4, bless you. What do you end up with again? What is this? Indeterminate. That's a very special situation, indeterminate. See, because you're going to say, hey, I have a vertical asymptote. I'm going to say, no, you don't. You have a hole there. How do I know? Yeah, because this rational is not simplified. So you want to simplify your rational. How? By using what? Algebra. You're going to factor, ladies and gentlemen. And your x minus 2's go away. So this question is the same as the limit as x goes to 2 now for x plus 2. And so by direct sub, plug in the 2. What's 2 plus 2? This, ladies and gentlemen, is the limit. Okay? So notice, I'm not even looking at the curve. So if we do look at the curve, and I just read this, they're saying use the top function for when x is not equal to what? 2. So, okay, use the bottom function when x equals 2. So when x equals 2, remember, this over here, this f is really what? This is your y. So this location here is 2, 1 for the top. Okay. I'm sorry. Not for the top. For the bottom. This is where 2, 1 would be. Down here. Now you might say, what does this all mean here? Well, you already know the limit as you go to the left and the right around 2 is 4. You just demonstrated that here. But this was a rational that was not simplified. You don't have a vertical asymptote. You have a what? You have a hole there. All right. So let's ask you this question here, because this is what the whole point would be. Could you tell me what f of 2 is? 1. Now it's defined. You say, how do I know it's defined? They just defined it by putting a point wherever they wanted to put a point. That's all. They put a point somewhere. Okay, it's defined now. Just because it's defined, does that necessarily mean it's continuous at that location? No. So f still is what? Discontinuous at x equals 2. Okay, because you said why. Some people, they're going to say why. Because the limit as x goes to 2 of the function does not equal f of what? 2. That's why. They're going to ask you to explain why. That's it. So this is kind of a whole other set of questions that, you know,